Hello and welcome to another with something new, with something different, something interesting, and something very much knowledgeable for you people. As I've been discussing with you, the alkane series, the hydrocarbons. So let's start today. The cycloalkanes. As a name itself, it suggests that it has something to do with cyclic structures. What are cyclic structures? That has something to do in a ring form, in the loop form. So today our topic is cycloalkanes and the skeletal structures. I'm Professor Dr. Moina Akhtar Mughal from DR.Mchem. You can see DR.Mchem, Institute of Chemistry, University of Sindh, Jamshoro. So I thought I must start something interesting so that we can again be on the track. So what I wanted to discuss today is about cycloalkanes and the skeletal structures, right? So what are cycloalkanes? These are the alkanes. Okay, these are the alkanes that has carbon chains in rings or loops, and are named by simply adding the prefix cyclo to the alkane, right? And for example, a six-membered cycloalkane that has got 6 carbon atoms, right, along with the hydrogens, is called cyclohexane. Now the structure of cyclohexane is as follows. You can see. Okay, the structure for cyclohexane is CH2, 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 again a CH2, and a CH2. So this is a cyclohexane. Cyclohexane. A very simple example so that you can easily follow the structure of cyclohexane. That you can see it is in the loop form, or a loop form, or in a ring form. Now it's in a ring form. You can call it in a loop form or in a ring form. See, so this is cyclohexane. Now cyclohexane has the formula C6H12, right? Whereas hexane has the formula C6H14. Now here there is a very important point to note that as general formula for alkanes having single ring has 2 less hydrogens than the open chain, whereas general formula for cycloalkane having single ring is CnH2n. This is the general formula for alkanes. Now, due to the tetrahedral configuration of carbon skeleton regarding cycloalkanes, the carbon skeleton of cycloalkanes isn't planar. It isn't planar, and it is important to note down that always that cycloalkanes having planar configuration or planar condensed structures present no knowledge or information regarding their conformations, right? They do not provide any information or knowledge regarding the conformations. Now what are the conformations we will study in our further in my next video. I will show you all the conformations which are very much important to learn for these cyclic compounds. Now there's an important way of drawing the cyclic structures. It is how by simply drawing the skeletal structures, right? The skeletal structures show only the carbon-carbon bonds, and in this notation, a cycloalkane is drawn in a closed geometric figure, as a closed geometric figure. Now, when you draw a cyclic structure for the compound, or you can say cyclohexane, you will simply see that each carbon of the vertex, each vertex has got a carbon attached to it, right? Carbon, or you can say that carbon and hydrogens are there at each vertex. So now for open chain alkanes, the skeletal structures would be, for example, for hexane, what it could be like. It's very interesting. 1, 2, 5, like, right? And it could be written like this also, 3C. One, two, three, four, five, six, right? So this is it. See how interesting it looks. Now always remember that whenever you are drawing a skeletal structure, remember to put a carbon at the end of the chains also. That is here and here, that is here and here also at the end of the chains, right? Because it's very important to note that when you are doing the nomenclature, you forgot to put the carbons at the end. You forgot this carbon is there or this carbon is there. You always forget. So because I also forget sometimes, so it's always keep this thing in your mind that there are carbons at the end of the chains also. Okay, and now in the above structure, that is 6 carbons here. 6 carbons of hexane are shown by 4 vertices, right? 1, 2, 3, 4 vertices are there, right? And 2 at the end of the skeletal structures, 2 at the end of the skeletal structures, and that is this end and this end, and 4 are the vertices. So now we have followed that whenever we are writing down a skeletal structure, it is important to not to put the carbons not only at each vertex but also at the ends of the structure. So the 6 carbons of hexane in above structures are indicated by the 4 vertices, which I just explained to you. So now here are other examples now of the skeletal structures. Let's draw some other examples to follow. For example, now how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now I start numbering them. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And there is a branching over here and over here. So what would be the name of this interesting skeletal structure? At the 2 position there is a group attached, and at the 6th position again there is an attachment. So what you are going to write it down, it would be like 2,6-dimethyl decane. It is 10. 2,6-dimethyl decane, DECANE. This would be the structure and this would be the formula, 2,6-dimethyl decane. There is another example also, so that is also very interesting. I draw it for you just now. Now this is a very interesting structure. It looks like some a cartoon is running. Let's draw. Okay, and over here this line. Okay, so this is a very interesting skeletal structure. Now here simply you are going to count down the numbers. It's what would be the name of this. Of course you'll start numbering from here, 1, 2, 3, 4, 5, 6. So it would be like 3, 3, 4 triethyl hexane. 3, 3, 4 triethyl hexane. So this is very interesting and very great to know. The structure for the compound is 3,3,4 triethyl So now I've explained you few skeletal structures. So it is important to note that when you talk about the nomenclature of cycloalkanes, it almost follows the same rules that are used for the open chain alkanes. Right, it is almost the same. Now I'm going to show you a few more examples right now, because without looking at the structures, you will not be able to follow what I mean to say, how you are going to write down methyl cyclobutane and 1,3-dimethyl cyclobutane and compounds like that. So let's focus on the compounds on the paper, right? So I'm going to draw it on the paper for you people, right? So just wait. Okay, so now the structure for this is a very interesting compound. You are going to draw a square only. So now there is a methyl group at one end, right? What you're going to name it? How you're going to name it? Methyl cyclobutane 1, 2, 3, 4. So what would be the name? Methyl cyclobutane. This would be the name of this compound, methyl cyclobutane, right? Whereas I will draw, there's a space enough. Okay, draw one more compound, again a square, right? A square. Now a square has two methyl groups, CH3. Okay, what would be the name of this compound? 1,3-dimethyl, two methyl groups, dimethyl cyclobutane. 1,3, again a dash, dimethyl cyclobutane. This would be the name of this compound, 1,3-dimethyl cyclobutane. As we start the numbering from here where the methyl group is attached, so it would be 1, and this is the 3 position, so 1,3-dimethyl cyclobutane, as it has 4 carbons in it. So this was the structure, this is the compound. I hope you are following it. Okay, now next structure, it's also very interesting. Okay, so you have a methyl group over here, and you have a ethyl group at this point, C2H5, right? A methyl group and a ethyl group. Now how you are going to name it? 1-ethyl, 2-methyl cyclohexane. Now when there is we have an option of ethyl and a methyl group, you are going to move according to the alphabetical order. So as E comes first, so you are going to write down 1-ethyl, 2-methyl, 2-methyl cyclohexane, cyclohexane, according to the alphabetical order. Now we have used here the alphabetical order, that is 1-ethyl, 2-methyl cyclohexane. My drawing is a bit, it's not that good. I did a mistake over here. It's not a bond, it's only a skeletal structure I've shown, and I just wanted you to use the nomenclature. You must know how to draw the structure. So this is it, 1-ethyl, 2-methyl cyclohexane, by using by writing them in the alphabetical order. Now here you have to notice one thing, that whenever we are it's not necessary to use the prefix 1. That is, prefix 1 is not necessary when you are using for the mono substituted cycloalkanes, when there is only a single substitution. But when there are 2 or more groups, then of course you need to number them. You need to number them when you have more than 2 substituents. And of course numbering would be starting when to give the substituent the lowest number, as we have been doing previously with other examples. So keep that thing in your mind also. So I hope today you found all these interesting information regarding the skeleton structures of different cycloalkanes. I hope you find this video interesting and you will learn it and you will practice more about the cyclic structures. Thank you very much.